Hello, everyone. Welcome back to Jump On Air. We're so happy you've chosen to spend some of your Wednesday with us as we explore statistics, science, data, and of course, Jump. My name is Julian Paris. I am the Learning Strategy Manager here at Jump Software. And as always, I get the great privilege to be your host for Jump On Air. We have a great show for you today, full of really wonderful speakers who have knowledge to share and stories to tell you about. And so throughout the program, I'm going to keep us on track as best I can by referring to this schedule. I also do that because I want you to know that if you have to leave, you can always come back and make it for your favorite segments. So if you do have to leave, remember the one link to know, jump.com/jumponair, will connect you right back to the live stream no matter what device you're on. So if you need to leave, make sure you come back and catch those segments. Now, if you can't make it back, or if you really have to go, we're sorry to see you go, but you can always catch the on-demand recordings of Jump On Air at our community page. community.jump.com/jumponair is the link to remember. There you can get the on-demand full episodes from every day we've been on air. You can also watch the individual live segments, and you can interact with our presenters. So if you have a question about something they shared, go ahead and ask a question on the community, and they would be very happy to help you out and talk through what they've done. So community.jump.com/jumponair. Now, I always like to start the show with some kind of segment, and this time it's going to be a little bit different because my colleague and co-host Ryan always likes to ask me really interesting questions about Jump. And so what we thought we would do is a segment called 5 and 5 in 5. So it's 5 questions that he has, 5 answers from me, and we're going to do it all in 5 minutes. Ryan, nice to see you.
Hey, thanks, Julian. I have got to tell you, I've learned a ton of things on Jump On Air. I really appreciate what I've learned from you and all the presenters, but I have some really simple questions that I don't really want to necessarily ask either in the chat or on the community. Do you mind if I cover a few questions with you, a couple simple ones?
Fantastic. Yeah, let's do it.
Okay, so I think I have like 5 of them. All right. If I have a distribution, can I change the order of the histogram bars for a categorical variable? Let's say I'm looking at big class at age. Can I do that descending or ascending, or do I just have to live with the default?
Yeah, that's a really good question, Ryan. So I'm not going to use big class. I feel like we use it a lot on this show. Let me open a data set that actually came about from last year when I went backpacking with one of my best friends. And I got a little bit obsessed with measuring the weight of all my items. And so it actually was a perfect thing because I did just what you asked because I was interested in the different categories of items I had. So I went to distribution, I grabbed category, and I was interested in the total weight. So I actually put weight as a frequency variable here. And if I look at just the overall, these are ordered alphabetically. And that wasn't what I wanted. I wanted to know what's going to take up the most weight in my pack because I was looking for shedding ounces if I could. So your question was, how can I arrange these bars in descending order? Now, as you know, we could probably go to the category variable and set a value ordering under column properties. So if we wanted to be specific about the order, we could set it here. But I don't want to go look up the actual weight of these and then order it manually. You want it an automatic way. So the way to do that is go to that red triangle. Under order by, there's the option to do descending or ascending. Now it says count, but I've ordered these by, or I've frequencied these by weight. So actually that's the weight descending. And so now it's ordered by descending order of weight. And the sleep system is actually taking up the most weight in my pack. Now, bonus tip, if you want to save these value orders to that column property I just showed, you can save it right here. So I'm going to save that value ordering. And so now in that category will always be ordered by weight if I want. And just so you can see that, I'm going to go back to the column info here, and you'll see the custom order is set there. And so it's a really cool thing to be able to do that. Yeah. So I'm going to turn that off for now. Great question, Ryan.
Okay, thanks. Yeah, that's definitely going to be useful. There's so many things under that red triangle. All right, so the next question is somewhat related. For a tree map, can I arrange the rectangles in the order of size? Like, sometimes the biggest one's not in the left, and I don't know exactly what order they are. Can we customize that so it appears differently?
Yeah, that's a great question. So, yeah, let's go to Graph Builder and let's just produce that basic tree map in case people haven't seen it. And so I'm just going to make this bigger in a second. I'll take category again, put that on my X here. And you'll see the first thing that happens is it just puts on, I have actually the graphics here as my value labels or as my labels for the items. Cool. But I'm going to turn on the tree map here. So that's up here in the elements list. And as you mentioned, it's just ordering them to fit into the space well. Let's actually order it in a squarified way. So with the biggest at the left and the smallest at the bottom right. Under the tree map control panel over here, and so always look in your controls because there's lots of things, and actually under layout is the option to do a squarify layout. And so that's actually going to rearrange these now in that order. Now, you'll notice comfort here is listed at the top, and previously we saw that the sleep system was the most. I still have to do something. I have to put weight in for my size because right now it's ordering by the most frequent items in the data set. So there we go. Weight's now in there, and you can see my sleep system again ranks as the highest. Bonus tip, right click, make sure to go to hover label and turn on something like a tree map here, and you can get those drill down tree maps now. So I can see within my sleep system, it's my sleeping bag that's taking the most.
That's great. There must be something a little bit with your presentation. Your mouse pointer is a little bit off, but I totally get the point when you were looking at the red triangle and stuff like that. So anyone that's watching, you're like where you're going to be. But that's perfect. Thank you. That's great to be able to customize that. Okay, so I guess for my third question is, I love how in JMP that you can select points in one graph and you can visualize them to linked other, like a data table or another graph, and it's got to be one of the most powerful things. So if I'm in something like a matrix where I have a bunch of points and I want to see a bunch of rows instead of just one row, is there any way that I can group or like roll over a bunch of points at one time or a zone inside one graph and see it in the other?
Yeah, let's check that out actually in the iris data set. And so I'll produce sort of what you were just asking for. And I'm sorry about the mouse being a little bit off. I can tell on my other screen that it is. But I'm going to grab these different measurements for these different flowers, and we're just going to make that scatter plot matrix that you mentioned there. And then let's actually get another graph, because you're right, that global selection of points is so cool. The fact that you can select in one plot and see it in a graph as well as even in the data table. So let's just arrange these side by side. So you mentioned something really cool. We can select a point, all points, and see them, but you wanted to roll that around. And so there's a really neat tool under the tools menu, and it's called the brush tool. It used to be the only way you can do brushing in JMP. So I'll grab the brush tool, and what it does is what you just described. It gives me a selection that allows me to move across points. And what I can do is hold down the Option key or Alt on Windows and resize that brush size. And so now I can drag that selection over different places. And so it's a nice way to see the relationship among really the points in those different graphs, but also select them in this sort of dragging, brushing type way.
So the Control and Alt, you just drag the actual little square to get that?
Yeah, so the Option key on the Mac or the Alt key on the Windows. That's right.
Okay, perfect. All right, fantastic. Okay. All right, so my fourth question would be, hold on a second, let me cue it up here. I wrote these down. All right, if I have like a huge wide data table, like tons of columns, and I'm trying to find that one column, I've added a bunch, and I want to drill down into that one specific column very fast, is there any way that I can navigate to that column without having that arduous way of scrolling horizontally in a data table?
Sure, yeah. So I'm not going to pull up a super wide data table, but this one's 39 columns. And if I wanted to get to the end, you're right, I'm going to have to, scroll. That's kind of slow. There's always a fast way in JMP. Navigate to the column you want in your columns list on the left and just double click it. That'll take you right to that column in the data table. Yeah, and bonus tip, if you always want that like clipped to the edge of your table, select it, go to the columns menu and use that scroll lock or unlock feature. This is like freeze panes in Excel, and it's going to lock it to the left. So now if I scroll, it always stays there. So I use that all the time for those columns you want to clip to the edge of your table.
All right. So there's my final question is a little bit on the personal side. As I'm getting older and my glasses are kind of changing, I'm having trouble sometimes depending on what I have on the screen. Is there any way that I could make the text or the numbers bigger for myself, but also when I'm demoing without having to go into preferences and keep them permanent?
Right. That's a good question. And that comes up a lot. So if you're running on a very large screen, that can be a real issue. So I just produced some output here. And if we wanted to change the font sizes for everything, go to that view menu and you'll notice there's the make text bigger and make text smaller. It also has a keyboard shortcut on the Mac, Command minus or Command plus. So I'm just going to use those keyboard shortcuts and do a couple Command pluses, and you notice it scales everything
right. Beautiful.
up and down. So this is
that is really nice. Yeah. That's terrific. Well, that's all I have for today. I really appreciate it. I'm going to go ahead and practice these, but I'm sure I'm going to have more. So thanks a lot, Julian.
Outstanding. Thanks, Ryan. Thanks for joining us. All right. So that was today's 5 in 5 in 5, which was more like 5 and 5 in 7, but hopefully you learned some new things. All right. Moving on, let's get to our main program. I'm really excited that we have our Director of R&D, Shannon Connors, who's recorded a segment for us exploring your personal health data with custom mapping. And Shannon, some of you may have seen at our Jump Discoveries talking about these same personal health data. So we're really happy that we have this segment for you from Shannon Connors.
Hello, I'm Ann Milley, and welcome to Technically Speaking, Analytic Solutions to Real-World Problems. Today's topic is how to use and create custom maps to explore your data in a different way, which can lead to new insights and exciting discoveries. In this example, R&D Director Shannon Connors uses personal workout data to learn more about her past and present exercise patterns. You'll walk away with a better understanding of how to manage dirty data, along with how to create maps as graphical selection filters.
Today we're going to talk about a few different points and discuss how they apply to one of my own projects. We'll talk about the power of working with personal data, using visualizations to help you identify the need for data cleanup, creating custom map shape files for your data, and the use of selection filters. We'll also talk about how creating custom views of your data can help you better understand your own patterns. If you stopped by my poster at Jump Discovery in Cary in 2014, or if you've read any of my blogs in my fitness and food series this year, then you've probably seen some of the Graph Builder graphs that I created with the help of its lead developer, Dan Gregg. I've collected several years' worth of activity monitor data, sleep, and food log data, and getting the data out of all the various different apps that I use and into Jump has really helped me improve my JSL skills, get more familiar with Graph Builder in general, and then learn a thing or two about myself and my patterns in the process. Working through a personal project in Jump always gives me plenty of ideas that I can then turn around and apply to my work-related projects too. My Jump blogs and my Discovery project really helped me to connect with other people who are part of the Quantified Self community, and I had the opportunity to attend and give a short show and tell talk last year at QS15, last June in San Francisco. If you haven't heard about it yet, the Quantified Self community includes a lot of people that are interested in many different kinds of self-tracking activities, many of which involve internet-connected self-tracking devices. So Quantified Self really connects to this larger concept that's commonly referred to as Internet of Things, or IoT. The Internet of Things is important both at the large scale for companies, cities, and countries, but it's also becoming increasingly relevant at the personal level as wearable technologies and home monitoring devices become more and more common in our lives. I find that people tend to track the things that most interest them. For some, it's monitoring their home environment. For others, it's monitoring themselves and their health. I even have a device that's shown at the lower right of my devices on the left that's called the Push Strength Band, and it tracks information about all the reps that I complete in all my weight training workouts. And it uploads the data onto my iPhone so that I can download it and do work with it. But it wasn't always this way. Like many Jump users, I've got a lot of historical data and a lot of information about my workouts, but it isn't sitting in a set of files that require scripting to combine like my project last year. It's actually contained in this long series of handwritten notebooks. I've kept paper notebooks with details of all my weight training workouts since I started doing it in high school, and I've actually kept workouts dating back to 1998. It always seemed like it would be way too much work for me to get that data out of my notebooks and into electronic form so I could do more with it. But I finally decided I would tackle this project. Now, I know you're probably thinking, why didn't I try OCR on my notebooks? And I did, but it really just didn't work very well for the format that I use. I find it was actually faster just to enter the data manually. So early this year, I started to take little chunks of my early morning time to enter my data for my notebooks into a spreadsheet. I started with all my January workouts since I had recorded workouts during about 14 of the last 17 Januaries. Of course, January is a great time to be motivated by New Year's resolutions, and so I thought I'd start there. So what information exactly is contained in my historical weight training records? Well, let's talk a little bit about the metrics that I tracked, in case you're unfamiliar with weight training. So tracking metrics for weightlifting is different than tracking for cardio exercise. With cardio, you're usually tracking your time, your distance, your steps. Maybe you're looking at routes via GPS and possibly tracking, what kind of a workout was it, steady state, intervals, etc. But on the other hand, weightlifting data tracks metrics about the actual lifts and movements that you perform. Many people automatically think of maximum weight lifted, and sure, that's an interesting metric to follow, but working near or at your upper strength limit often can greatly increase your risk of injury. I'm not training for a powerlifting competition, and I've been training for many, many years, so I've got a really good idea now of my upper strength limits. And I'm actually more interested in tracking the volume of my training instead. So the metrics that I track include metadata about the workout, the date, the time, the duration of the workout program that I'm following, the specific name of the workout, and the exercises that I performed in each session. I map every exercise onto a specific primary body part area that it works, and then those body areas can be separated into body zones, so upper body, lower body, and core. For each exercise, I then track the amount of weight that I used, how many repetitions of the movement I performed, and how many distinct sets of reps that I performed. Using all these component pieces of information, I then calculate a total weight lifted metric for each unique combination in each of my workouts. I can then sum that information up at various different levels. I've shown 2 example exercises here to illustrate those metrics. So total weight lifted is the sum of the 2 weights used times the number of reps times the number of sets that I completed. So on the left we have a dumbbell chest press, and that maps onto chest as a primary body part and upper body as a body zone. And total weight lifted is the sum of the 2 dumbbells, so for example 60 pounds, 30 pounds in each hand, times 12 reps times 4 sets. So that gives me about 3,000 pounds total weight lifted for that particular exercise on a particular day. And dumbbell hammer curl, use less weight for that, so maybe a sum of 30 pounds times 12 reps times 4 sets, so somewhere around 1,500 pounds. And so that's how I calculate the total weight lifted metric, a primary metric that I use to look at my workouts. So here's a picture of my data table containing information that I entered about my workouts and my exercises. Currently, the table is about 10,000 rows worth of data, and I have multiple rows per workout that detail each unique combination of exercise, weight, and repetitions that I did on each of those days. Once I had my table ready, I was really excited, and so I started to make some graphs to explore my workout volume. But immediately I noticed a big problem with my table. I hadn't standardized my exercise names, so I had a lot of redundancy there. So here are some different variations of names that I used over the years for the same exercise. So in the left blue shaded area, there's some names that I used for dumbbell bicep curls. And now these are all occurrences of basically the same exercise in my workouts, but by naming them different names, then all of their information sums under different names. It makes it more difficult to find overall patterns. And on the right side, you can see the situation's even worse for dumbbell chest presses, which I used about 7 different names in my workout logs to refer to exactly the same exercise. So clearly I needed to do some sort of aggregation step if I was going to make sense of my patterns. And I had a variation of different misspellings that occurred. There were some different orderings of words and different names. And clearly, there's some work to be done before I could really do much of anything graphics-wise. So I grouped and filtered my exercise names till I ended up with a consolidated set of unique names that I liked. For each movement, I had a set of items that were original item names and a cleaned up item name that I consolidated them underneath. And I added the new information as a new column in my table. And I used JMP's Recode platform to perform this process, and then I saved out a script a recode script that I could then reload in the dialog when I got a new set of workouts into my data table. And I could view my groupings, and I could tweak them as needed, and I could add new groupings, and then save the script out again, and I had a nice repeatable process for cleaning up my table. I started out initially creating some relatively simple graphs of my training data in Graph Builder. So I was exploring the length of my workouts, the timing of my workouts, and then the total weight that I lifted during them. I was amazed at how well my data actually recaptured the days of the week that I usually worked out that year. So this is my data from 2014. And my workout schedule in 2014 included scheduling workouts on Tuesday and Thursday early in the morning, workouts later in the day on Saturday and Sunday, and I would occasionally work out at lunch on Monday, Tuesday, and Wednesday. And you can see this reflected in the middle element, the heat map element. You can see my start times being captured by my data, and then the total weight lifted reflecting the days that I primarily worked out, showing up as having the most total weight lifted. I also explored my data for those workouts that I completed during New Year's resolution time in January's, and it was certainly interesting to see how my patterns changed over the years. Back in grad school, I used to lift regularly in the gym several times a week, but when I switched in the intervening years to much shorter home workouts, my volume dropped off pretty considerably. In recent years, I've been ramping up the volume on my workouts again and lifting more total pounds in my upper body than my lower body exercise. So in contrast to my grad school days, when I did a lot of lower body work, as you can see from the blue bars on the left being fairly large, on the right side, in current days, I'm doing a lot less of that lower body work. But I really have to thank Zan for pointing me in the direction of JMP's custom mapping. With the incorporation of this into my project, it really evolved into this fun opportunity for me to learn more about creating custom maps, using them in Graph Builder, and then also using the new JMP 12 selection filter feature. I built various different dashboards with my custom maps, and I used them to explore my data and understand my patterns. These maps have been really helpful for me for putting my data into context. First, let's talk a little bit about map shapes in JMP in general. When you open Graph Builder, you'll see a lot of different drop zones, but the one I want to focus on is in the lower left side of the window. If you drag a column into this map shape field that contains a map-associated name like state or country, etc., that's found inside one of JMP's built-in maps, then JMP will automatically recognize it, and it will add map shapes into your graph. You can then color by your data to color the map shapes accordingly. You can also add custom maps into your map library to help JMP recognize other types of map shapes that go beyond the standard ones that are built in. There are a few great JMP blogs out there that show examples of custom geographic maps, like the zip code map that Zan created and posted to the file exchange shown on the left. This custom map was created by importing a set of existing shapefiles from another source and converting them into the format that JMP recognizes. But the Shape ID field can also be used to display smaller scale maps. For example, you could display locations in a building and color the room shapes using temperature data, like the building floor example on the bottom. You can look up Audrey's blog if you want to read more about that. Mark Bailey from SAS Education also published a blog on creating custom shapefiles for a microtiter plate. Really, the possibilities for creating custom shapefiles are endless. And you're not left on your own in the process of creating custom maps. Thanks again to Zan for pointing out the existence of a freely available add-in on the JMP File Exchange that lets you create custom map shapefiles by tracing shapes in a picture or line drawing. The shapes can be anything that you can draw with line segments. For example, the add-in was used to create that floor plan diagram that I showed on the previous slide. When you download the add-in, you drag it into JMP to install it, like any other add-ins you would install. From then on, it appears in your add-ins map shapes directory. I've included a link to the user community where you can find this add-in, which is free for you to download. In my case, my shapes of interest were body areas containing major muscle parts on a female body. So I looked online for a free JPEG of female muscle structure, and I saved it to a file on my computer, and then dragged the file into the custom map creator window. The most time-consuming part of this process, of course, was creating all the different lines for the different shape segments. It took me a few hours to trace the various areas for both front and back, And it's not perfect, and in retrospect, it could have been more detailed in certain areas, but you get the basic idea. Fortunately, the add-in did all the work for me of recording the information about my custom map. The add-in populates 2 files as you trace your shapes. One file defines the names of the shapes, and the other file defines the points along the boundaries that create each shape. Once I had made these files by tracing around all the different muscle areas, I placed them in a directory under my user area in the roaming folder. Note that that's the location in JMP 12. The pre-JMP 12 location was under App Data Local. So getting back to my data table now, I've got a relatively simple bar graph script saved that just tracks my total weight lifted metric over months and years. So let's just play that. Okay. I use transform columns to create month and year variables from this simple date variable that I had in my table over here. And I drag them onto the x-axis to create this nested axis that you see down in the x-axis. This is a pretty nice overall view of the total pounds that I lifted over time, but it's not very informative about other variables in my training history. So let's open up the Graph Builder control panel. So one option for understanding this data better would be to add an overlay variable like body zone. Now I can see that the point that I mentioned earlier, where I'm lifting about the same poundage that I did back in grad school, but I used to do a lot more lower body work back then. It's fairly balanced, as you can see. The bars for upper and lower body are about the same height over here, whereas now I'm doing a lot more upper body work. You can see the green bars are much taller than the blue bars down here for upper body and lower body. Also, interestingly, I used to do weighted core exercises. You can see there's a light blue bar over here on the left, but I really don't do any of those anymore, so those have largely disappeared in my current workouts. Now, I even like the option to make this a stacked bar chart. And it's a little bit harder to tell the relative length of the green and blue bars now, but you can clearly still see that the blue bars are a lot lower in recent years and the green ones are quite a bit longer, even though the total poundage is fairly similar, and that's a little bit more apparent with a stacked bar chart. You can also see here in the middle of the graph where I was doing shorter, lower volume workouts for lack of time, and of course this impacted the total weight lifted metric that I'm tracking. Now we could take this stacking one step further and change the overlay variable to overlay by primary body part. And this is going to change my bar chart now to have a different colored bar for every different body part that I worked. So where am I spending my time now in the gym compared to where I used to spend it? Not surprisingly, given the last graph that revealed the overall patterns by zone, I'm now working my shoulders and my back and chest more and legs less than I used to. But you can now see with so many body parts in this graph that it quickly becomes very cluttered. Although someone who's really familiar with the data like me might really enjoy looking at it and comparing the bars, it's pretty hard to judge the relative length of the bars. If you saw Zan's plenary talk at Discovery or you watched the recording, then you would see this is one of the things that he mentioned about stacked bar charts. So this is where filtering really begins to help. I can use this toolbar icon to add a local data filter to the graph. And now I can find primary body part and add that as a filter variable. And now I can click through a list of body parts to see their individual patterns. So I had mentioned earlier about ab exercises. Weighted ab exercises used to be quite a large part of my workout training program. Back in grad school, not so much now. You can see when I do ab exercises, they tend to be body weight only, so they really don't impact my metric much. And so if I look at other body part areas like calves, you can see, yes, I used to do a lot of calf exercises back then, mostly heavy toe presses. Really don't do those anymore. But it's interesting to look at other areas and to see where I'm working them more or less than I used to. All right, well, we're going to close this graph down for a minute. And it would be pretty cool to be able to visualize my overall patterns, but really drill down into specific body parts. So let's get some shapes for my custom map in here. So first I'm going to open up a new Graph Builder window, and I'm going to drag in primary body part into the map shape zone, And as you can see, as I do that, my shapes appear. Now, there are certain body areas that I traced, but don't have any data for them. So I have to add in that little show missing option. And I wanted to do a little bit of cleanup on the axis range, but I really don't need these labels, so I can actually go in here and change the tick marks and remove those. I really don't care about seeing those since they don't really have any relevance for body measurements or anything like that. So I'm just going to go in the axis settings and remove those. Alright, so now I've got my map shapes and I've got my axes cleaned up a bit. Now I might want to color by something, and so let's go back to that total weight lifted metric that we talked about earlier. Now I'm going to color my shapes by my total weight lifted, but the scale is not really that appropriate because it goes from 0 to 2250, but I've got this hot and cool, and that's just not a very good gradient for this unidirectional type of scale. So I'm going to go in, I'm going to change my color scheme, and I prefer this yellow to red. It's like a muted yellow to red. That happens to be my favorite color scheme, so we're going to use that. And so now I've got these areas where, as you can see, I mentioned before, used to do a lot of calf workouts. Certainly shows up there as a hot spot. And I could say % of total if I wanted to kind of look at every different area saying, where have I proportionally spent most of my time? So I changed my summary statistic to % of total. And now I can get some idea of, over the years, what body parts have received the most total weight lifted in my workouts. So now I've got my body shapes and I've got a graph. Now I'm going to make use of JMP's Combine Windows functionality to create a combined report that contains both the graphs we've created. So I'm going to check the box here to do a combine windows for these graphs. I'm going to remove my local data filter because I really don't need that right now. And I'll check the box in this window and kind of move it over to the side. And now I'm going to say combine selected windows. And now I've got a combined report that contains both my body shapes that we just colored by, proportion of total weight lifted for those areas. And I've got my bar graph stacked by different primary body parts. And now what I want to do is, if I just clicked now, you can see that selection is linked. So if I click on shoulders, it'll click on the shoulder bar in the right side graph. But what I really want to do is use my body area graph as a filter for the other graph. And so to do that, I click on the red triangle here and say Edit Application. And now the application that I've created opens up in App Builder. And I can right-click on the graph that I want to use as a selection filter and just say Use as Selection Filter. And now when I run my application, I get a window that looks like the one I created before, but when I click on the different body part areas, it now updates the graph on the right to show only the area for those specific areas. So now I can see bars for, say, if I just wanted to look at upper body, I could click a couple different areas and add them to the graph. But if I was only interested in looking at one at a time, now I have a way to filter and, for example, only look at biceps or maybe only look at calves and look at those patterns. And now I can see how the graph matches up with the map of the areas that I'm interested in. All right. Let's look at another example. First, I'm going to clean up a few windows here. All right, so we're back to my body part graph and the stacked bar chart. But maybe I've decided that I'm interested in drilling down into particular body parts to try to understand my individual exercise patterns throughout this whole time frame. So I've got a graph with a nested axis that's got exercise within body part. It's a little bit cluttered, I would say. So this is a little difficult to make sense of, except being able to say, what are the very tallest bars? Okay, dumbbell flat chest press, I mentioned it before. It's something I do a lot. Got data here on 3-point row, which is a back exercise I like to do a lot. But maybe I'd like to make sense of this graph by putting it in the context with my other filters. So let me just rearrange these things a bit. Make my window a little bit smaller here. Add my total weight lifted window over here. And now I've got this graph too that I'd like to add to my application. So now I'm going to combine the selected windows. And now I've got all three graphs in my application. And again, I'm going to repeat my step where I open an app builder, and I right-click on my selection filter, say Use as Selection Filter. And now when I run my application, I've got my body part area, and both sets of graphs are now updating. So I can see not only for a particular body part area how much total weight I lifted for that area, but I can also see which exercises specifically accounted for the most total weight lifted for that exercise. So if I'm interested in shoulders, then I can see, certain kinds of shoulder presses were pretty prevalent in my workout logs, etc. Another thing I wanted to mention is that these graphs are live while they're in the application with the selection filter. So if I was interested, I could actually go back and show the control panel. Maybe I wanted to show something different. So for example, maybe I was interested in adding a different summary statistic for my total weight lifted. So I could say, okay, let me add total weight lifted over here. I'm going to, we'll go back to a bar. I'm going to change this particular bar to a line. And now I want to change the summary statistics. So I'm not looking at the sum anymore. I want to know what was the maximum amount of weight that I lifted over this time period for these different exercises. And now I have that information there. So I hope this presentation has given you a few new ideas about how you can use JMP with custom maps, and given you some other ideas about using selection filters with your own particular. Thank you very much.
Outstanding. Thank you so much, Shannon. I'm so glad we were able to have you on, recorded for that. Do interact with Shannon on the community segment page, community.jmp.com/JMP-on-air. I'm sure many of you may have questions about some of the things she did, so make sure to interact with us. And I'll make sure to put the link to that very special add-in that helps you do the map shapes so that you can also find that on the segment page. All right, in our next segment, we have Ross Matusalem back for another edition of Help, this time to take us through the question mark tool.
Hi, everybody, and welcome to another edition of Help, review of JMP's help resources and how to use them effectively. I'm Ross Matusalem, systems engineer, and today we'll review the question mark tool, which allows you to access the help documentation simply by clicking right on the thing in JMP that you want help with. The help documentation is a detailed resource that you can use to learn JMP or reference specific information while you're working in JMP. You can always access it by going to Help, JMP Help, which will take you to our online documentation. The documentation is searchable by clicking in or typing into the text field at the top, or browsable by using the interactive outline on the side here. The question mark tool just provides another way to navigate the help to find the information that you're looking for. So let's take a look at an example. I'm going to open up the Hollywood movies dataset, which is in the sample data library, and just perform a quick analysis. So using the distribution platform, I'll take a look at the distribution of the world gross revenues for the movies in the dataset. So here's the standard distribution platform output. And you may notice right above the histogram, I have an outlier box plot. And there's a fair bit of information in this box plot. We have the box and whiskers, we have the points, we have the red interval, the diamond, the vertical line. There's a lot going on here, and maybe I don't remember exactly how to interpret everything I'm seeing. Now, if I know what the name of this thing is, a box plot, I could go search the help for box plot, or I could even browse the help for the distribution platform and find the information I'm looking for. But instead, I'm going to use the question mark tool to just get right into the help from inside this JMP window. You can invoke the question mark tool in the toolbar at the top of the window just by clicking on the question mark there. You can also find the question mark tool under the Tools menu. Or my personal favorite, you can use a keyboard shortcut. So you can't see that I'm doing this, but I'm just going to type a question mark into my keyboard here, and it pulls up the question mark tool for me. So once you see this your arrow replaced by the question mark, you know you've invoked the tool, and now you simply just click on the thing you want help with. So we're loading up the help page, and you can see that JMP has taken us directly to the help page for the outlier box plot. So maybe you're in a situation where you don't really know what to search or browse for, but you want to access the help for something, or maybe even do know exactly what to search or browse for, but you just want a more quick or more direct route from inside JMP to the external help documentation. The question mark tool is the tool you want to use there. So with just a couple minutes we have left, and for edification purposes, let's see exactly how that works under the hood. So back in our analysis output, I'm going to show you what the underlying structure of this report window looks like. So I'm going to show the tree structure here, and in this window, you can actually see the structure of the report window, kind of in its hierarchical structure here. And notice in a few spots, you will see these little tags here that say help key. So these are essentially pointers to the help documentation that the development team has dropped in under the hood in various places in this window so that JMP knows where in the help documentation to send you if you use the question mark tool to click that particular element. You can see a number of these help keys throughout this window. So there's one at the top there. You can actually see here the help key for the outlier box plot. And as we scroll down, you'll see a number of additional help keys. So what this means is that there are multiple places I can click on in this window and get help on those specific components. Just to show another example, I'll invoke the question mark tool and click on the summary statistics table. And here we're taken directly to the help page for the summary statistics. So once again, this is just a really great direct way from inside JMP to the help documentation. You can see our developers have taken the time to think about what documentation pages you might want to see for individual elements in these reports, and then place those little help keys in there for you. So the take-home point here, the question mark tool is your direct route from within a JMP window to the help documentation. You just invoke the question mark tool, either in the toolbar, the tools menu, or by using the keyboard shortcut. So just type a question mark. Once you have the question mark invoked, just click on the thing you want help with. So that's it. Back to you, Julian.
Outstanding. Thanks so much, Ross. And I'm so glad you showed how that worked in the hierarchical structure of the outlines. It's really cool to see what our developers do to make sure we can all use JMP effectively. In our next segment, we have another edition of Ask Dr. DOE, where Don McCormick is back to help us understand, is one factor at a time okay when my continuous factor settings depend on my categorical levels?
All right. Howdy, everybody. Thanks for coming back. And I got this question a couple of weeks ago, and basically the idea here was that a person was very simple experiment. They were running a two-factor experiment where one of the factors was categorical and the other factor was continuous. For example, they had a chemical that they were interested in investigating, and concentration of the chemical. Chemical had two different types that they could use, and the concentration, and here is the thing that made it a little bit problematic, is that the concentration depended on the chemical type. So the question I got was, well, shouldn't I just run this as two different experiments because the concentrations weren't the same for the two different chemical types? And the answer is absolutely not. This is, you could take advantage of a design of experiment even when those continuous factors that are dependent on the categorical factors are not the same. So let me actually illustrate a couple of different situations that we're going to talk about. Okay, so I see this come up quite a bit, and there are two cases where I see this come up fairly frequently. So our typical, and again, I'm going to make this very simple.
Sorry to interrupt you, Don. You're not sharing your screen, just so you know.
Oh, okay. How can you see the screen now?
Nope, not yet on my side.
Sorry.
There we go. Thanks.
All right, fantastic. Sorry about that problem. So here I'm going to illustrate this with a very simple two-factor experiment, although this is extendable to more than two factors. So here's the case where we've got a categorical factor, in this case some sort of chemical. I've got two different types of chemical A and B. I want to run those chemicals at two different concentrations, high and low concentration, 1 and 2. Now, the typical situation is something like this, where I can A can take on the high level or the low level, 1 or 2. B can take on the high level or the low level. The situation that I was asked about, or when this seems to be problematic to folks, is this. So I've got my two different chemicals, but the concentrations are different. And in this case, there is an overlap. There may be overlap, but there doesn't necessarily have to be. So here I can only run chemical A at concentration 1 and 2. I can only run chemical B at concentration 2 and 3. Now, should I do this as 2 experiments or 1 experiment? And in most cases, when you're thinking that to yourself, absolutely not. This could be run as a single experiment, and you're going to certainly be much better from an experimental design standpoint if you do that. There is one other case, too, that we're going to talk about where this does come up, too, and that is when, for whatever reason, I have an application, some factor I'm interested in, and that factor only applies to one of my levels of my categorical factor. So, for example, let's say I'm looking at adhesives, and I've got 2 different types of adhesive, A and B, and I'm interested in even, let's say, two different the amount of adhesive I'm going to use. How well does it bond? But let's say A requires some sort of heat step that B does not. There's a case where I've got this additional factor that applies to only one level of my categorical factor. So that situation occurs as well. And this might happen, for example, if B is one of your control groups, and you're not really applying those levels of your other factors to that control group. Okay, so that's kind of fairly often. Now, as it turns out, it's very fortunate that when I was discussing this problem with the folks, Jump On Air folks, Brad Jones was tied into the emails, and let me just exit from here. And as it happens, fortunately for me, he recently published an article on this particular topic. So let me show that to folks who are interested. Very technical in nature. However, it covers a number of different situations where both of those situations happen. Okay, so in this case, the case where I've got different levels, and the case where I've got these missing factors that apply. And as a matter of fact, I'm going to use a couple of the illustrations from this article to illustrate what I would do in JMP. Now, there's good news and bad news here. The bad news is that while it would be wonderful to be able to design and analyze experiments as they were done in this article, first of all, the analysis is somewhat complex. And from the design standpoint, the design is not completely implementable with the DOA platform. However, with this article, Brad has provided some JSL scripts that illustrate how the DOE part is implemented. Now, that said, the good news is that a lot of this can be approximated. Certainly, the designs that we're going to look at can be approximated very closely using what you already have in JMP without having to worry about scripting. The analysis part for the first situation that I talked about, you can implement in JMP fairly easily, approximate fairly easily. The second one is a little bit more difficult, and we're not going to talk about that. We don't have time. So what I'd like to do is I'm going to start with that very first scenario where I've got a categorical factor, and the categorical factor, the continuous factor associated with it depends on the level of that categorical factor. Okay, so we're going to I'm going to, again, and I thank you, Brad, for sharing this with me. We're going to talk about a case where and I'm going to just show you the illustration from the paper. I've got a pharmaceutical preparation, and I've got 2 different steps in that pharmaceutical preparation. Step 1, step 2. Step 1 requires a buffer or a chemical, and that chemical can be of 2 different types. However, if we take a look, we look at the in this case we're talking. This is pH. The pH is different in the case of buffer 1 or buffer 2, so it matters what buffer I have. Now, to make things even a little bit more complicated in this case is that I've got a second washing step, and in that second washing step, I've got 4 different buffers. Okay, I'm going to consider 4 different buffers. And again, the concentrations are different for each of the buffers. Now, if you work in the pharmaceutical or biotech industry, this should look fairly familiar. This happens quite a bit where I've got, let's say, assay development. I've got a number of different steps, and in each one of those steps, I've got some sort of wash or some sort of a detergent, and I want to look at different types. But things like concentration, pH, temperatures might change from type to type. Okay, so how would I set this up in JMP? All right, so the good news here is the setup for this particular case, because I don't have any, let's say, any cases where for one of the buffers, say there was no way to vary pH. To save a little bit of time here, I actually pre-populated my my dialog box. So a lot of this is going to look fairly familiar to you. I've got 2 categorical factors. One is the buffer at step 1. Okay. The second is the buffer type at step 2, and that's 4 level. I've got 2 different pHs. The pH is for step 1, pH for step 2. So exactly like you would set it up in the normal situation. So I would go ahead and build the model that I was interested in looking at. And in the case, I believe, of the example in the paper, it was only a main effects that they looked at. So we're just going to keep main effects in the model. And I believe it was a 24-run experiment. Okay, so exactly like I would set it up in the normal case. Now, here's the thing. So what helps us in this situation is that we're going to keep when we design the experiment, we're going to keep those continuous factors in their the orthogonal, the coded version, where -1 is the low and +1 is the high. So that's the way we're going to design the experiment, and the design will comes out like we want it. Now, when we go to analyze it, and here's one of the complications, when we go to analyze it, what we're going to want to do is we're going to want to substitute, where we had -1s and +1s, we're going to want to substitute those actual values that we saw in the experiment. Now, at this point, it becomes a little bit more complicated. It's harder to reproduce the model. It's in the paper. However, we could still use this as a basis and fit a model to the data in this situation. And it has a model. JMP to save the model to the data table. I am going to nest, since these pH levels are really particular to the buffer type that they were associated with. I'm going to nest them in the pH in step 1 in buffer type 1. I'm going to nest that, and we're going to do the same thing with. So, when you read the paper also explains how these are nested variables. Okay, I'm just going to go ahead and run that. And again, approximation of what you see in the paper. It comes close. It's not exact, but it's certainly allows you to at least design the experiment in a more efficient way than running this as, in this case, you probably would have run this as potentially 8 different experiments. And you don't want to do that when you can avoid that. Okay, let's talk about the second situation now. The second situation is a little bit more difficult to certainly, we're not going to talk about the analysis. The analysis is certainly beyond what I can cover today. We'll talk about the design, and the design is going to be approximated by what I'm going to show you how to do in JMP. And it's once you do this a few times, you get the hang of it. It's really a nice feature to know about within JMP. So let me actually show you what the experiment is, and I'm going to scroll. This is the chicken feed experiment, and here's a case where what I'm trying to do is I'm trying to see whether or not a particular enzyme has an effect on growth in chickens, and the enzyme is given to the chickens at 2 different levels. However, there's a control group here, and this control group doesn't get either of the enzymes. Now, how do I deal with that? I mean, again, should I deal with this as 2 different experiments, or can I set it up as a single experiment? And the answer is I can set this up as a single experiment. So let's go ahead and do that. I've got that pre-populated just so we don't have to watch me type in values. So here I've got my enzyme, and I've got 3 different levels. I've got 1, 2 in my control. I've got dose. Now this is going to be a little bit different than what you might be used to. Now a couple of weeks ago I did a Ask Dr. DOE, and I talked about continuous discrete numeric factors. What we want to do to make this easier to design is we want dose as discrete numeric. And it's going to have, in this case, I'm going to look at 3 different levels, 0, 1, and 3. If I wanted to have a quadratic effect with dose, I'd put a 4th level in there. Okay, something in the middle of 1 and 3, maybe 1, 2, 0, 1, 2, and 3. So here's the idea. What I want to do is I want to tell JMP, when you design the experiment, make sure that control does not get doses 1 and 3. Make sure that enzymes 1 and 2 don't get dose 0. All right, so I'm going to set it up to make sure that that condition is met. Now, how would I do that? Well, certainly. Let me start by saying I'm going to modify the model. I'm not going to stick with the default model. And again, I'm interested in. I'm gonna remove dose. I'm just gonna look at a main effects model. I'm just gonna look at enzyme and dose. I am gonna take. Let's see. I think in the paper it was looking at I think 15 runs. So number of 5s for the case without the quadratic effect. To make this work, what we're going to do is we're going to use the disallowed combinations filter. That's going to allow me to say, don't use these combinations. The discrete numeric, the reason I use that discrete numeric is that it makes it easier for me to do that, because JMP, the custom designer, will not consider the values in between those discrete points. Okay, so let's do this. Let's start out. I'm going to grab, since it's dependent on both, I'm going to start with the control first. I know that the control can only take on level 0. So what I'm going to do is I am going to disallow those cases where the control is 0 and the dose is, in this case, because it's discrete numeric, it's going to be anything that sits between 1 and 3. If I had a 2 in there, it would discount that as well. Okay, I'm not done yet. I still need to add in the condition for my 2 different enzymes. All right, so I'm gonna just click the OR button. I'm gonna add in my condition on enzyme 1. Now I know that enzyme 1 cannot take on value 0. So the way I'm gonna set that up is, again, I'm gonna say for enzyme 1, 0, but, and this is something that's important, is that I don't want to include 1 here. I want 1 to be considered as being a viable value for enzyme 1. So by default, it's going to try to exclude 1, but I'm going to say exclude the maximum there. And you'll notice what happens is that the line next to the 1 changes from solid to dashed. All right, 1 more. Got to do the same thing for enzyme 2. And let me turn off the maximum. Now I am ready to go. Let's go ahead and run the design. Give that a second. It's going to compute an optimal design, and it's going to give me a design that's very similar to what you've seen in the paper. What the design that was generated through the scripts that were the supplementary material. All right, let's go ahead and make the table. And there's my design. I believe in the design it actually would only had 3 control values and not 4. But again, this is an approximation. We'll give you the capability of doing the design as one experiment. It's certainly better than running these as separate experiments. Okay, looks like I am almost out of time here, but before I end, let me ask Julian, are there any questions, anything that come into the Q&A window before we leave?
No questions about your particular, what you've shown. Someone asked you if you can increase your font size, but what we can do is on the recording of it, we can zoom in for you. But nope, doesn't look like you have any substantive questions, but I invite everyone, of course, to interact with you on the segment page. Because if they do, I'm sure you'd be happy to answer.
Absolutely. Well, thanks, Julian. That's all I have today.
Outstanding. Well, great. I'll grab the screen back from you. And thanks again, Don. Just a reminder to everyone, do interact with Don and everyone at the community page, community.jump.com/jumponair. You can ask questions. You can suggest segments as well. So if you have a DOE question for the doctor, make sure to put it in there and get your questions answered. In our next segment, we have Ryan DeWitt back to take us through another Have You Tried, this time exporting GIF animations in JMP.
JMP has supported the reading and writing of images for some time. It now supports images with multiple frames, such as animated GIFs. GIFs are typically low-memory file size animations. These small GIFs can of course be shared in email, a blog, or several other document types. Using the flu sample data available in JMP, I'll start by clicking and running the first bubble plot script. There's a local data filter ready to go using region. I'll select and filter the first 2 regions to compare them. I'll increase the speed sum using the slider. I'll offset the region titles from the bubble by clicking and dragging them. I'll then select the play button to preview and make sure this animation is what I'm going for. It's animating using the advancement of date, so I'll restart by sliding the date slider back to start. And this time, I'll select the record button, then select play. When the animation concludes, I'll stop it with the red icon and then select the file save icon, then choose an export destination. It automatically loads into a browser to preview the results. And this animated GIF can be shared with someone who doesn't have JMP. All you need is an application that displays animated GIFs, such as a browser.
Outstanding. Thank you so much, Ryan. Yeah, be sure to try that out. It's a great way to embed those graphics, especially into things like PowerPoint, where you'd still want to show some of that interactivity. In our next segment, we have back Elisa Hunt-Lowry, who is taking us through her new segment of Quality Corner, where she takes us through Statistical Process Control. And we are seeing your screen, but not seeing you or hearing you, Elisa.
All right. Can you hear me now?
There we go. Yeah,
all right.
Perfect.
Thanks, Julian. Well, again, welcome everyone to today's Quality Corner. And I'm Elisa Hunt-Lowry. I'm a systems engineer here at JMP. And I'm going to talk a little bit about SPC. And SPC really encompasses all the methods and tools used to monitor and improve product or process quality, and really reducing variation. And the key to talking about variation is to talk about 2 different types of variation. One is common cause, which is answering the question, is it stable over time? This is going to include all the people and processes that you would expect to see on a daily basis in your process or product. Special cause variation is assignable cause variation. Is there a specific event that triggered that variation? So an example of this, if you're working from home today, but you normally work in the office, common cause variation might be, well, typically before our current world events, maybe you work from home because you were sick, or you had a loved one who was sick, or maybe you were had a house maintenance appointment scheduled. Special cause variation in this process is working from home because there's a pandemic. The common theme that we're going to talk about today with measurement systems analysis, process capability, and control charts is all variation. So let's talk about the first topic. Measurement system analysis. What is it? Well, what we're doing is we're assessing our measurement system. It's the analysis that includes our process, which could be the ruler, it could be a thermometer, timer, etc. People, standard, and procedures involved in measuring a process. And in our case, it could be, we're answering the question, what is the true value? And so we're going to talk a little bit more about that, about bias and accuracy versus precision. And there's really a range of techniques that we can use. So here, we're going to talk about a practical example for most of the rest of the session. Due to COVID-19 and working from home more, I decided to build a desk for my treadmill. So along with my husband and teenage daughter, we did that. So let's talk about measurement system analysis as it relates to that process. So to create that desk, I had to cut some 60-inch 2x4 boards. So I could help, so let's use MSA to discuss this. So bias occurs when the mean has shifted or there's consistent error. What if the tape measure I used was missing 2 inches? Linearity comes into play when we're using the wrong device to measure something. What if I use my 6-year-old's 5-inch ruler to measure, to cut the board? Could I add variation to my process this way? Resolution is the ability to discriminate between changes. So what if my daughter measured to a 1/16 of an inch, but I only measured to a 1/4 of an inch? Stability is what happens over time. What if I forget the operational definitions? For example, I forgot to align the board and measure it from the center, or next time I measure it from the top or bottom. Oftentimes, this is why equipment needs to be calibrated. And finally, what if I'm just inspecting the board, checking to see is it within the 60 plus or minus a 1/4 inch, or is it outside? Then that would be an attribute MSA, which I won't discuss today, but we can certainly do that as well. So there are sources of variation, and another way variation can really be broken up into 3 components. Part-to-part variation, which is just the normal variation that we would expect to see from our manufacturing or our process. We have variation from the measurement system, which includes the operator and the device, which is the equipment or gauge. And the way we are going to look at variation is we're going to talk about it in terms of sums of squares. And sums of squares is really just measuring the distance from the average, and then taking the difference and then summing them all together. So this is just a measure of variation. So we're going to focus on precision errors, or the variation portion of measurement system analysis. We're going to talk about repeatability and reproducibility. And so repeatability is the variation due to the measuring device. It's when the variation observed when the same operator measures that same part repeatedly using the same device. Reproducibility is the variation due to the measurement system. It's the variation observed when different operators measure the same parts using the same device. So what does that look like for gauge R&R studies, which is what we're going to talk about today? We have the variation, of course, is broken into those 3 parts. And so the reproducibility is the variation from the operator. The repeatability is the variation from the gauge. And so typically the criterion that we use for an excellent measurement system or good measurement system, we want the percent contribution of the measurement system variation to be 10% or less. Let's talk about cross versus nested studies. Cross studies are assuming that each operator can measure the same part more than, and each operator can measure the same part more than one time. And so we want to have, we want to be able to, for the 3 of us to be able to measure that same board more than one time. Nested studies are assuming that the part is destroyed. For example, what if we were doing a breaking strength test on the board or a flammability test for a piece of fabric? So for example, the operator, we would have to assume a part was the same, and there's some methods that you can deal with that. Would love to talk to you more about that. So let's talk about this board length example. So to do a good measurement system analysis, when you have continuous data, 10 boards are selected to represent the expected range of the process variation. So typically we want 80% coverage. That means we're not going to choose 10 boards that have been manufactured back to back to back on the same day, same supplier, etc. We want 80% coverage. So maybe pick boards from different suppliers, different times of years, etc. And 3 operators are going to measure those 10 parts 3 times each. And so here's the instructions on how to do this in JMP, but I really just want to focus on the output. So does it look like there's variation within operator or between operator? Yes. So Elisa has a lot of within variation. Isabella does too, but not as much. Robin doesn't quite have as much, and maybe he has a little bit more experience, except for perhaps part number 1. And so we see the average variability chart at the top, and then we see the standard deviation plot at the bottom. So the question we want to answer is this an adequate measurement system? When we look at the output here, we're going to see the output of the gauge R&R, the percent of contribution is 21.47%. Now that's much higher than our 10% criterion. So our answer is no, we don't have a good measurement system. But what would we do here? We would stop in terms of our investigation, and we can see that the components, that most of that variation is coming from the repeatability or the gauge, and only a small part is coming from that reproducibility. So maybe we want to address that within operator variation, where you saw that high variation for Elisa and Isabella, and perhaps investigate that first and improve this measurement system. Next, we're going to talk about process capability. Process capability is assessing a process's ability to meet customer expectations using a unitless capability indices. So the example I have for this initially, just to discuss process capability, is driving your car into a garage. So imagine your car is a process, and the left and right sides of the garage are our upper and lower specification limits. Now, what happens if we drive a car into our garage that's too wide? Well, it won't fit. And so we're creating defects on the left and right sides of the process because our process is too wide, or we have too much variation. What happens if our variation has been reduced, but then we're too far to the right and we're not centered in the garage? We're still creating defects. What we want in this process, and we'll relate it back to the board example, is we want to be centered and on target in order to be meeting our customer specifications. So let's talk a little bit more about process capability. What we're doing with process capability, if you look at the equations down below, is we're looking at this ratio of this voice of the customer to voice of the process. So I told you we were going to tie this all back to variation, right? So the voice of the process, this is our six standard deviations. And there's different ways to calculate standard deviation, and it's calculated for short-term variation or standard deviation and long-term standard deviation. You can see those equations there. And we're going to talk about, if you hear CP, that's really short-term. It's using the equation for short-term standard deviation, and PP is using the equation for long-term. So what is a good process capability indices? Well, it depends, right? It depends on what industry you're in. Generally, most organizations will say something greater than 1, but if it's more critical, maybe it's a 1.33 or 1.67 or perhaps 2. So it really just depends on your industry. What are some of the assumptions that we have? for process capability. One is that we're assuming that the process is stable, so maybe no special cause variation is present, and we could perhaps validate this assumption by using a control chart. And the second assumption is that the process is normally distributed. However, in JMP, if it's not normally distributed, we would want to fit that non-normal distribution and then do our process capability. So here's an example in JMP where we're looking at the length example of the length of our boards. And we're going to go through, and the first thing we're going to do is we're going to check to see, using the Shapiro-Wilk goodness of fit test, check to see if the data is normal. So we're validating our normality assumption. And yes, since the p-value is greater than 0.05, the data is normal, so we can go ahead and use the Analyze Distribution platform to assess the process capability. Here, we didn't have any rational subgroups, and you can see that we have both the output for the within or the short-term process capability, as well as the overall, the long-term process capability. So our question here that we really want to answer is our process capable of meeting customer specifications? And here, because the PP and the PPK are both less than 1, this process is clearly in need of improvement. And we can see the difference, that there's a difference between the PP and the PPK. The PPK takes into account how close we are operating in respect to our closest specification limits. PP is assuming that your process is centered. Here, I can see that my average is about 59.8. So I'm actually shifted to the left just a little bit. And so if I wanted to improve this process, I would want to shift to the right a little bit. But even if I shifted to the right, my PP is still not going to be quite close to 1, so I would probably want to reduce that variation as well in order to improve this process. All right, control charts. Control charts are sometimes control charts are used synonymously with the term SPC charts. And that's okay as well. Of course, control charts were created 100 years ago by Walter Schuhart, who worked for AT&T. Well, it was Western Electric, and it eventually became AT&T Bell Labs. And control charts are just a way to monitor your process over time to see if it's stable. And so they're really just this sophisticated run chart. Well, what does control charts detect? They detect 3 things: changes in process average, changes in process variation, and they look at different sources of variation. And remember the 2 sources of variation that we talked about early on, common cause versus special cause? Control charts are going to identify whether we have special cause or common cause variation going on. And so some of the benefits is, of course, we can distinguish the signals from the noise, the signals being the special cause or assignable cause variation. And it will allow us to look at stability around the mean, and also to detect if our process is shifting up or shifting down. So let's talk more about control charts and control limits. So control charts use limits to identify signs of trouble or special cause variation that's present. And so here you see a chart, and you see those control limits, so those red bars here. Well, how are those calculated? Remember, variation has to do with the process. So those are calculated as the green line here is the average, and it's calculated plus or minus 3 sigma from the average. And that's where those control limits come from. And so here in this abrasion control chart, I have a point that's falling outside of my upper control limit. So that's going to be assignable cause variation. Typically, most things, not everything, but most things inside this blue shaded area, this is due to common cause variation. And so that's what we want. We want most variation in our process to come from common cause, not necessarily from special cause variation. So what does JMP use to identify whether something is common cause versus special cause? Well, when Schuhart created these charts 100 years ago, he came up with these Western Electric rules. Now, there's some obvious ones. For example, like the 0.1 being beyond the plus or 3 standard deviations. And then there's some other ones that are not so obvious. The great thing is we don't have to remember these rules, is that JMP does it for us. One other thing that's interesting about the control charts are there a wide variety of control charts. I only listed a few of them here that JMP can create. But what type of chart? Well, typically you would start off by asking, well, what type of data do you have? Are you measuring something with a gauge, like time or temperature, or are we counting something like defects? If we have continuous data, we're going to use something called an IR chart, which is an individual moving range chart. If we have those rational subgroups that we talked about earlier, if with the rational subgroups between 2 and 9, typically we're going to use an X bar R chart. If that rational subgroup is greater than 10 or equal to 10, then we're going to use an X bar S chart. For discrete data, we need to really ask ourselves, well, are we counting defectives or are we counting defects? Or defectives is also considered like the percent or percent defects, right? And then we also ask ourselves, is the sample size constant? Well, the great thing about JMP is, when I used to teach SBC, I had these rhymes in my head where I had to memorize what type of chart to create. The great thing with JMP is I no longer have to do that. That with the control chart builder, it's easy to do. One other thing that I'll note, and this is taken from a book called Introduction to Statistical Quality Control, 4th edition by Douglas Montgomery, is remember we talked about the control limits and how those are calculated plus or minus 3 standard deviations or sigma. The estimates of sigma are all calculated with these constants that Schuhart came up with 100 years ago. So, and a lot of this information is also in the JMP documentation. So how do you create a control chart? This will be available in the JMP community so you can see the steps. What we really want to focus on is the control charts. And once we perform the test, we really want to answer the question, is the process in statistical control? Now, this is an individual moving range chart, and JMP knew that from the continuous data that we gave it, and because down here we didn't give it any rational subgroups. So with control chart builders, it's really super easy to use. I don't have to memorize any rules or rhymes or roadmaps. And in here, I want to ask myself, is the process in control? After we actually ran the 8 tests, it's telling me, no, it's not in statistical control because it's violating test number 1 and test number 3. Now notice there are also 2 charts here. There's one at the bottom and there's one at the top. The one at the bottom is the moving range chart, and so the moving range is simply the difference. When we have an IR chart, it's simply the difference between the first 2 observations. And so in this case, we have 50 observations, so we're gonna actually plotting 49 here, so you can see there's not one plotted for number 1. And so this top chart is going to give us information about detections or changes in the process average. And the bottom one is going to tell us about changes in our process variation. And I can see here for that moving range for around observation 23 that I did have a moving range that was really outside of that control limit. And so this is letting me know, this bottom chart is letting, for continuous data, is really helping me to answer that question, what's happening with the process variation? Is it changing or shifting? And this top chart is telling me whether or not I'm having shifts in the process average. So in summary, SPC, at least the way I define it, it just encompasses, it's all looking at variation. That's our common theme, whether it's measurement system analysis, process capability, or control charts. MSA is really assessing your measurement system because you really want to eliminate or reduce that measurement system error as much as possible and make sure you have most of your variation for your part-to-part. Process capability is assessing whether we're meeting customer specifications, and then control charts are just identifying whether the process is stable and in control. And finally, just in case you're wondering, yes, the treadmill desk did get built. And then finally, for more information about these quality methods, I would highly suggest that you check out the free online course called Statistical Thinking for Industrial Problem Solvers. Julian, I'm going to stop here and see if we have any questions.
I don't see any coming in yet, but we can give people a second or two to think of some questions and put them in the Q&A. Again, if you don't have that Q&A panel out, you can just pop it up and ask your questions there. Yeah, if you like, we can actually do a quick 2-minute break to give people time to ask their questions. You want to do that, Elisa?
Sure, absolutely.
Sure. Yeah, let me do that. I'll put it up on the screen here. So that was 2 minutes. You may have seen some of the questions that came in, Elisa. If you have your Q&A panel up, I can also read off to you if you like.
Okay, let's see. And I'll start with the bottom one. In JMP 15, can you shade sigma zones in chart SPC Builder? I haven't tried it in 15. I know in 14 you can create reference lines and you can shade those for sure. That's a little bit more manual, but I will check into that and I can follow back up if you want to, if this person wants to follow back up with me in the JMP user community.
Yeah, there was one it looks like there exist tables for distribution modelization, I guess, for the fitting.
Yes, absolutely. If you go to Analyze Distribution, one of my favorite tools or ways to do process capability is under Analyze Distribution. When you go to Analyze Distribution and then the red triangle hotspot, there are different continuous fits, and I'll just pull something. I'll pull that up right here. And when you under the red triangle next to length, if you want to fit a distribution, you can fit a specific one, or if you want to fit all, you can do that as well.
And we're only seeing the corner of that window, it looks like.
Oh, I'm sorry.
No worries.
It's in my other screen. So if you go to the red triangle and you go down to continuous fit, you can fit a specific distribution, or you can do a fit all. So absolutely, if you want to identify that distribution before doing process capability.
Outstanding.
All right. I didn't look at the other questions.
Yeah, I don't see any others coming in, but We're nearly out of time. Are there any final words you'd like to leave people with or additional tips?
No, I would just encourage them to check out STIPS, and we have a lot of free resources on the JMP user community.
Fantastic. Well, if anyone does have additional questions, be sure to check out the segment page, community.jump.com/jumponair, and we'll have the recording of this segment up there, as well as a place for you to ask questions if you have them. So thanks so much again. In our next segment, we have RT Meidel back to do another edition of our Mindful Moment.
Hello, everyone. Welcome to the Mindful Moment. My name is Arti. I'm the social media manager for JMP, and I'm also a yoga teacher. And today I'll invite you to do a little bit of movement followed by a little bit of breathing. So to get started, I'm going to move my chair back so that you'll be able to see me. And so come to the front of your seat so that your feet can rest on the ground. And to begin with, just rub your palms together vigorously so that you feel a little bit of warmth. Your palms from sitting at the desk, your hands might have gotten cold. And then just shake your hands out. Give them a little bit of a break here. Make your hands into two tight fists and then open your fingers wide. Spread the fingers wide. And then flick your fingers all around. Up, the sides, down, everywhere. And then we'll grab. So grab with your hands, just giving your hands something different to do here than to deal with keyboards and phones. And then just relax your arms down and roll your shoulders a few times up toward the ears and then down and back. And just breathe. And then place your hands onto your thighs. Now your hands, as we do this movement, are going to move toward your knees and then back. So grab onto the fronts of your knees to begin. Inhale, press your chest forward and look up. And then let your hands move back a little on your thighs as you round your spine and drop your head on the exhale. So this is the inhale, grabbing onto the fronts of the knees, looking up, bringing the chest forward. And then exhale, reverse, rounding the spine, letting the hands move away from grabbing onto the knees, straightening the arms, really rounding the spine here. So it's just spinal flexion and extension. So inhale, come forward, look up. Exhale, rounding the spine. Once more like this, inhale, pressing the chest forward, looking up. And then exhale, reverse, rounding the spine and lowering the head. And then come to sit up tall again. Inhale the arms up overhead. And then exhale, twist to one side, bringing one arm behind, one arm to the outside of the knee or thigh. Inhale the arms up overhead. Let's go to the other side. Inhale up. Exhale, lower. Inhale up. And exhale, lower. Now come back to the center and pick up, let's say, your right foot and put the ankle onto the top of your left thigh. There's a little bit of a stretch here for your hip. And just gently using your hand, you can press your thigh down, getting a little bit of a stretch. And then inhale, sit up tall here. And then exhale, just hinge forward a little at the hips. And then inhale, come back up to sit tall. And switch legs. So left ankle to the top of the right thigh. Press that thigh away, feeling for a stretch in the hip. And then inhale here, sit up tall, hinge forward. Notice the difference from side to side. Inhale back up. Let's try each side again. Right ankle to the top of the left thigh. Inhale, hinge. Come back up, and then switch legs. Inhale, sit tall. Exhale, hinge. Then come back up to vertical with your torso. Bring the feet back down to the floor. Place both of the hands onto your belly. Close the eyes if you can. So take a deep breath in here. In through the nose. Open the mouth and exhale. Now breathe in through the nose deeply. Really feel for filling up the belly so that your hands are moving underneath you as you breathe in. So feel your belly come out on the inhale and then exhale. Let's try that again. Inhale. Feel the belly underneath your hands. Exhale, release. Once more, inhale, filling up the belly. Expand, exaggerate the belly a little bit, and then exhale, release. Last time, inhaling, fill up the belly, exhale, let go. Release the hands back down to the thighs. Open the eyes gently if you've had them closed. Thanks for joining me. This has been your Mindful Moment. See you next time.
Thanks so much, RT. In our next segment, we're going to see another edition of Jump in Action. And this time we have Martin joining us to do the tables menu.
Thanks, Julian. Let me share my screen. So, today we talk about the tables menu, and in this session, and in the tables menu, you find a lot of different things. There's summary, the sort, the join, and all the concatenations of data tables. I will concentrate on the subsetting, the stacking and splitting, and the anonymize option. To start with a simple example, I just opened up two data tables you can work with. So the first data table is the popcorn trial you also find in the sample data. And you have two measurements for certain batches. So you have, for example, a measurement of the yield once measured and a second time measured. To do certain analysis, you need to have the data reshaped in a way that you can do this analysis. For example, if you want to do an ANOVA to compare those two measurements, it's harder to have it in this way. You can do it maybe with the graph builder, but for an ANOVA, it's better to have them stacked on beneath each other like you see it on the right side. One table with one column with one measurement for the yield, and then the yield measurement, so the first and the second measurement. How do you get to that? Quite easily. You go to the tables menu, and if you are not sure which one this is, it's here on the tables, and then you go to stack. Stacking means that you can simply put your variables, which are the measurements, all together in this field and try to stack them. There are many options, and I will talk about some of them. For the simple stacking, you almost have to do nothing else. Maybe you want to specify an output table name, or you want to label it correctly. For example, the data should be the yield in our case, and the label, which is which measurement I have taken, is my yield measure. I say keep dialog open if I want to check if everything is okay. If I'm sure that's fine, I can just press OK and get the table as I have it on the right side. There's another thing for those simple cases. When I have a tall table, like in this case, I have one column which has all the information in it, but I want to split it through another variable, which is usually a categorical variable, but it is not necessarily a categorical variable. So if I want to bring back this table to the original format, I can just use the split command and say I want to split the column, which is my measurement, the yield, and by which column I want to split it. It's a yield measure. Also, again, I can keep my other variables or I can drop them. I can keep the dialog open or save the script to the source table, which I would do if I want to have it in my original data table as a script on the left top corner. But those are just additional things I don't want to talk too much about. If I press OK, I get back to the original table. That's splitting and stacking for a simple case. So let's do it in a different way and more complicated. And this is what I can do when I have multiple series. So let's take a look at another sample data, the blood pressure, which I just slightly modified. So I have some coloring in it. And I have also added my 2 scripts here. So I can share and compare it more easily with you what this specific method of stacking does for you. Again, we go to the tables menu and say stack. So what do I want to achieve actually? That's the question you always should ask first. I have here several blood measurements. I have on the left side also my subjects, so I have different number of subjects. I have my doses for those specific subjects, but I have those blood measurements on 3 different times for 3 different days. The yellow one is the Monday measurement, the orange one is the Wednesday, and the red one is the Friday measurements for 8 in the morning, 12 in the noon, and 6 in the evening. What if you don't want to stack all the data in one column, but you want to have them in 3 columns, where those 3 columns mean all the measurements for one day? So for the Monday 1 column, for the Wednesday 1 column, for the Friday 1 column, or vice versa, you want to have it for each time. So all the 8 in the morning measurements, all the noon measurements, all the evening measurements in one column each. This is not easy with the simple stacking. So what can you do? And there come in those options you have in addition to the typical stack. So if we take all our measurements and say we want to stack it, if I don't do anything else, as before, all will be stacked into one single column and an additional column for the labeling, which will be the column names. I want to do a multiple series stack, which allows me that the measurements will be stacked in a certain way. But I have to understand what kind of series do I think about. Here I have 3 measurements each, which tells me what I want to get to. And so I can say my number of series is not 2, but it's 3. If I run this, I get this kind of table. And I don't press on OK because I want to show you also the coloring, so it's easier to understand what's happening in the background. So here you see that we have the first measurement of the blood pressure on the time of the day, blood pressure 8M for Monday, blood pressure 8W for Wednesday, blood pressure 8F for Friday. And you see that the measurements have been taken in a different way. So when I just bring them both aside each other, the first measurement was this blood pressure 8M. Then I get to 1, 2, 3 levels further, and that's the second pressure here on the lower end. But it is not really this way. You can think about it, but its first column will take this value as first measurement. This value will get into the second column. This column will go into the third column. Then the next column of this row will go to the next row, and so forth, as we have 3 series we wanted to have. If you would have 6 series, the numbers would be in one row for all those 6, and then for the first 3 here in the second row, and then the next 3 rows. So you would have a break which collapse all your data, which is not really what you want. So this is a way how you can go to the time of the day. So if you want to have all the different columns here, instead of, so the overlaying columns, instead of having those 3 columns. But what if you want to get the day actually? So have the first 3 columns in one column, then the second 3 columns, and then the third 3 columns. And you don't want to do it one by each other. Not much more difficult than before. We just have to press this contiguous option, which allows me to say what's going on then. And if I then just run this first script again, or the second script better said, I get a different kind of table, and you see that it has now a different numbering here, and it will take the contiguous after each 3, the first level, then the next level will be counted in the next row, then the next 3 will be put in the next row, and so forth. So that's the difference between those multiple series stacking, which you should be aware of. You have to practice, that's what I honestly have to say, to be sure that you do it correctly, and the keep dialog open is your friend, and if you have done it correctly, do it once more with the save script to source table so that you have it in your table as I have. So that was the stacking. Now let's get to a more complex method in the split and what you should be aware of. So here I have the drug measurement sample data. In the drug measurement sample data, you see there's a bunch of subjects. Some are measured 3 times, some are measured once, some are measured again 3 times, and others are just measured twice. You have certain drug types and the measurements for them. So what happens when you use table split and you take your drug type as a split by and the measurement as a split column? You can say, okay, and then what do you get? You get some missing values here in the lower end. That's not really what you want to do. And even worse, if I rerun this once more and recall and say I want to keep all the information and say, okay, I see that the subject has been completely scrapped up. There's no 2 anymore. There's twice the 11. So what happened actually? Again, the distribution can help a little bit to uncover what's happening. The B has measurements for all the 12 subjects. That's why we get all the 12. The A and the B and the C only have 10 measurements. So you get only the first 10, and the rest will be filled up with empty values. And the subject will be counted from the values which we have data for all those. So every subject where we have data for everyone. And then it just adds up the additional rows. That's not really what you want. What you want is that you go back into your split measurement, you say recall, and you want to have a grouping variable, which is in our case the subject, which allows you to exactly say which measurement belongs to which subject, and where the subject has no measurement for the certain drug type, we want to have a missing value in this. So if I press then OK, you see now the missing values get into the right place, and the subject has from 1 to 12 as we would expect. So that's something you should definitely be aware of. Finally, there's something what I want to talk about, the subsetting. And subsetting means you have something which is, of course, you can take a subset from data, you can take a subset from your visualization. What I want to share you is if you have coding errors. So for example, in this modified big class data, we have 4 measurements, 4-year measurements for those 10 peoples, and we just measured the height. And we have the sex here, but in 1 year we have a wrong measurement or wrong typed in sex category. So everyone is male, which is not really what we want. Of course, you can say I recode, but then I can only code F and M, which would have impact on everyone, which is not what I want. The subsetting means that you can select the matching cells for one variable or for multiple, go to tables, go to subset, and if you want to change something, like in recode, you can link the data to the original data table. We have additional options here which I don't need. So random sampling, stratified sampling. In our case, I would just want to have the selected columns. And I say, okay. And now I have here this field, and Barbara is definitely a female, so I said F. And if you look carefully, here's also an F now and added. If I copy that and say, okay, Jacqueline is a female and the ones here, and I make Control F, I have cleaned up my data table quite easily. I can just close the other data table and my data has been fixed. That's an additional thing for subsetting, which you might not have known before. As I'm running out, I just want to have 3 more seconds to show you the anonymize value. The big class families helps you a lot, or gives you a lot of different types of data. And when you anonymize it, it will change the data types into some anonymous ways. So you see, for example, the column names are all into X underscore column number. The nominal values are with a V column number, and then the category it has for a name, there are different names there. For the sex, we have just female and male, so 0 and 1s, and the numbers are staying there, but as well as expressions columns will stay the content, but the rest will be not readable anymore or interpretable. With that said, are there any questions? And Julian, we can go through.
Thank you so much, Martin. I don't see any questions, and we're right at the end of time. I do invite people to visit your community segment page if they have questions, but any final things you want to mention, Martin?
No, I think that's fine. Just practice. Practice your with the sample data. That's an easy way to not make any faults with your own data and learn how you can use those measurements.
Outstanding. Thank you so much, Martin. Thanks for staying up with us. Martin is overseas. In our final segment, we have Pete and Mary back for the tip of the day, where they act out a real-life scenario where a jump tip is the solution to a problem.
Welcome to Jump On Air's Tip of the Day with Pete and Mary. Today we are lucky enough because these tips from the community have been pouring in. So I have a hat full of different tips, and
awesome.
Yeah, let me grab one. And it looks like this one came in from Andrea, and that's a shocking surprise because I had no idea who that tip was going to come from. And I'm going to share a screen, and amazingly enough, I had made a PowerPoint with Andrea's picture on it. She is a systems engineer from the Midwest region, and she actually supports the Ohio Valley of the U.S. So she gave a recommendation to make combined data tables, and I have no idea how to do that. So hopefully, Mary, you do. I'm going to stop sharing, and hopefully you can take it away and show this.
Well, Pete, I got you back. I think I got this one.
Great.
All right. So this is data from a semiconductor wafer manufacturing process. You can see I have 406 columns, but what I'm most interested in is the equipment. So I want to look at an analysis of variance in NOVA. So the way that I know how to do that in JMP is to fit Y by X in my response. And I'm going to take all the equipment here, which is all my categorical process variables in my table all the way up to 200. I'm going to say, okay. And you're going to say, Mary, you nuts? What are you going to do?
I say that a few times a day. So, but you have 200 analysis. What are you going to do with that? That seems like a lot of work.
And what's interesting, if I come here, I can arrange in rows, and just so you know, there's 200.
Wow, that's a lot.
Yep. So so one of the things I want to get some statistics, right? I want to get some means ANOVA, and so one of the ways I know to do this, or the only way, is to use the control key, to hold the control key, which is the broadcast.
Okay.
You know, and there's another system engineer that says use this finger, hold the control key, and then go under the red triangle, and I'm going to select means ANOVA. Let go, and you can see all the way across, I'm getting all the statistics that I wanted from under that option.
Well, Mary, that's great, but you still have 200 reports to sort through. What are you going to do now?
Oh, but just wait.
Okay.
So I'm interested in the, my F ratio here, and I want to look at all of the 200. So if I right mouse click, I can get the option of make into data table, and if I do that, it's only going to take that one report. And what I want to do is make into combined data table. So I get the output of the analysis of variance output from the ANOVA I ran, and I want to sort on the F ratio. So I right mouse click in this column, select descending, and I want to look at the top 10.
So that's out of all 200. That seemed pretty easy.
Yeah. So what's interesting about that is I get my top 10 and I can go, so this is the particular processes. What I'm going to do is right mouse click. I'm going to copy. And I'm going to go back to my data table here. I'm going to go to fit Y by X again, because I'm only interested in the top 10.
Uh-huh.
I'm going to take my critical output parameter, and this is something really neat. Right mouse click, paste, and I can put in those top 10 variables that I felt are important to kind of take from 200 to 10 and take a look at them and continue my analysis and investigation.
Yeah, wow, 10 seems a lot more digestible. So just to summarize, you gave me 3 tips. You showed broadcast command. Broadcast with the finger. You showed you showed the make combined data table by right clicking on a report.
Yep.
And then you showed that you can copy out of a data table and paste into any kind of window. So that's 3 tips in one.
Yeah.
Dialog box, that's what I meant. Yep. Awesome. So this has been a super special 3 tips in 1 tip of the day from Pete and Mary. Thank you.
Andrea.
And Andrea, thank you. We'll see you next time.
Yep.
Outstanding. Thank you so much, Pete and Mary. Just a reminder, you can go to community.jump.com/jumponair, and there you can suggest any tip you would like for Pete and Mary to act out. That's also where you can see all of our on-demand videos, and remember to use the labels on the right-hand side that lets you filter to see any particular segment you want. So if you want to see just the tips of the day, go ahead and click that label and you'll get a page listing just the tip of the days. Make sure you follow us on all our social media channels. We have lots to share and we share it often. Make sure you check out your program guide. We have a really outstanding program on Friday, and we're so happy to have Vic Strecker here to talk with Ann Milley. So make sure to join us Friday. Share us with your colleagues. Jump.com/JOA is the link to share for them to get the subscription and to see the upcoming program. We hope you join us Friday, but until then, we hope you stay safe, we hope you stay healthy, we hope you stay close, even as you're keeping your distance. Take care, everyone.